Hello everyone, my name is Hassan Hussein. I am a prospective PhD student at Leibniz University of Hanover, Germany. And I'm also working as a research associate at the German National Library, also known as TIB. Today I'm going to introduce you the paper entitled Increasing Reproducibility in Science by Interlinking Semantic Artifact Descriptions in a Knowledge Graph. Here you can find the list of authors, and let's talk about the paper today. So, to give you a quick overview of the problem that we are talking about, so all of us know reproducibility is very important element in the science. And to make a good reproducibility, we need to follow the same procedure or steps that previous study that have made in order to get the same results. And of course, poor reproducibility can waste resources, and of course, that causes false or leading to a false conclusion, and of course that corrupt the public trust in science. The problem is getting harder because we have diverse of methods across different research fields. In this work, we present the ORCG template engine that improved the quality and the reproducibility of scientific artifacts. And on the top of that, we will introduce the reproducibility score, and we will focus mainly on four pillars, mainly availability, accessibility, linkability, and license. So what is ORCG? ORCG stands for Open Research Knowledge Graph. And of course, all of us know the problem of the current publication. So yearly, we have around 1 million published research article, journals, conferences, and that makes it very hard because it is still document based, which means it is either a PDF or HTML file. These file formats makes it hard for machine to extract information because it is unstructured format, and that's the problem that ORCG is focusing on. We are trying to transform this form of files into a structured format that machines can understand and humans as well. Here you can see an example of a paper created on ORCG. First, we have the metadata, the paper title or contribution title, and then we have publication date, number of citations, and research field, list of authors, DOI, and the conference that this paper is published on. And then the contribution itself for this paper is annotated in form of property resources, and that is saved in a knowledge graph in a format of RDF, which makes it easier for machines to inference the information and do and work on with this data. And of course, as you can see, the interface is user friendly. User can understand what this interface is about. Second important part of ORCG is the comparisons, and the comparisons allowed the researchers to make a comparison between different research papers or articles. So we have here a list of properties, and then we compare four or more, maybe more or less contributions. So the ORCG template engine is has some architecture, and it is mainly a subset of shackle shape. And this shackle is built in, or the structure of it is built like this. So we have a domain expert. They create a template on the template system with the help of the ontology lookup service. So we developed this service in TIB to allow users or researchers to use it. So with the help of this ontology service, and user can use the template system to generate a template using input form, and the information is saved to data or the RDF knowledge graph mainly, and then the reproducibility score is generated automatically. Another way, so the template is created, and then without user making this validation, they can create simply template and then leave it like that, and then user can the system can calculate reproducibility automatically. And then here, the community can give feedback to about the reproducibility, and also they can edit this template to improve it. But how the template looks like here, the interface for the template. So of course it has a description. You can add template name like this name, and description what this template is doing, and it is a set of properties that a user or template designer can create by themselves. So, for example, here this property name is of type number, has cardinality, minimum occurrence, maximum occurrence, and it has minimum value, maximum value. And we added recently this checkbox property is required for reproducibility, which means in order we telling the template designer in order to make this template valid for the reproducibility score, you need to take this checkbox to say, okay, this one is required, which means the user has to add the value for this one, this property when they create the contribution to be um, calculated under the reproducibility score. So reproducibility score architecture is designed as follow. So mainly we try to harvest the metadata as we saw in the paper format. When we create a paper, we harvest the metadata, and then the user select a template. System can recommend some template for the user, but of course they can create their own and then edit simply. And then when they select the template, the template is populated. So all properties of this template are added to the paper. Of course, user can add or remove more properties. And then automatically the reproducibility score is calculated when the paper is saved and all information are added. So, namely, as we said before, we focus on four pillars. Availability means all properties and values are available. And accessibility in RTG, we have different types of data. We have string, integer, resource, and URL. So when the type is URL, we check if this URL is resolvable with 200 HTTP response. And linkability means we allow users on RTG to link their resources with external ontologies like Wikidata, DBpedia, and Geonames, for example. So when this resource could be linked, it is highly recommended to improve the reproducibility of your artifact. And license is checked when this resource is of type URL. And yeah, as you know, almost every resource in the web has license, and we check for what kind of licenses this resource has. The implementation here is how it looks like. The reproducibility score, we have here two contributions. One is Sabah and this one is Sarawak, two cities in Malaysia. And we are trying to check the reproducibility score for COVID-19 score or value. So we give some information to the user about what this signs means. You can see it here. So this green check mark means the needed data is valid, which means the user added values to this property, and of course the score is 100%. The minus or this gray dash means needed data is unapplicable with also 100% score, and of course this red cross means not valid with zero score. So for example, we have a list of properties and the four pillars here, and then we calculate horizontally the reproducibility score for each property and vertically for each one of these four pillars. So here means this value is available. So we have the city Sabah, so the value is available, and because it is not URL, it is not accessible or unapplicable for this check. And here also in this, it is connected with ontology. And when you hover on this green check mark, you can see some tooltip telling you that this resource is connected to some sort of an ontology, and the same for license because it is not accessible, so we cannot anticipate the license of this one, and the same for the other properties. In summary, we have the problem of the reproducibility, and that can lead to wasting resources and, of course, leading to a false conclusion. We introducing the ORGG template engine allows defining the structure of contributions in a user-friendly input form and allow defining constraints on properties, and is implemented in a subset of shapes, constraint, language, or shackle. And our reproducibility score is focusing mainly on four pillars: availability, accessibility, linkability, and license. So that's all for today. Thank you for listening and joining me today. So here you can find my contact information, our website, org, and our GitHub repository, my email address, my LinkedIn, and ResearchGate profile. So these, if you have any questions, any you want to extend the discussion, please don't hesitate to contact me. Thank you very much for listening to me. And now time for questions if you have.